Hello, and thank you for joining me for the second half of the Section 1 information. Today we're going to talk about changes in state of matter. And so let's get rolling. So objectives. You'll be able to explain the 5 changes in state of matter that we're going to talk about. And then you'll be able to distinguish between which phases require energy to be gained and which require energy to be lost. So let's get rolling. So for starters, refresh my memory. How do particles in a solid move? And so if you think they vibrate back and forth, a liquid does vibrate, but they can also slide past one another. And so when a solid becomes a liquid, we call that melting. And that is this term here, which is solid becoming a liquid. When that happens, that takes place at what we call the melting point, which is the temperature and pressure to change a solid to a liquid. And that was one of your physical properties in the last unit. But it's the temperature and pressure to change a solid to a liquid is the melting point. Now, in order to do that, we have to have energy that ice melts because it gains a bunch of energy, right? So the question is, how much energy is needed to melt ice? Well, this is termed what's known as the heat of fusion. Heat of fusion is the energy needed to melt something. So each substance has its own heat of fusion. So ice has a different one than, say, carbon dioxide, which is different than gas, which is different than something else. But this energy is used to break the bonds between molecules so that they can flow past one another as a liquid. That is your heat of fusion. Next, how does molecule movement in a liquid differ than that of a gas? So we said solids are stuck, liquids can flow past one another. Gases, if you think back, they are free-flowing. They can escape their container, and this little molecule can go wherever it darn well pleases. And so when a liquid becomes a gas, we call that evaporation. If we add heat to it, we call it boiling, we call it evaporation. It's a change from a liquid to a gas is there. Boiling is evaporation that occurs throughout a liquid at a specific temperature and pressure, but they do the same thing. So the liquid is becoming a gas. When we do this, this happens at what we call the boiling point, which again we did that last unit, but that's the temperature and pressure at which a substance goes from a liquid to a gas. And when it does this, it requires what is known as the heat of vaporization. This is the energy needed to change a liquid to a gas. And so different substances require different amounts of energy, but we call that the heat of vaporization is the energy they need. Next question, can gases flow? Can gases flow? Yeah, gases can flow, meaning they can slide past one another. That's the flow part. So gases can flow, liquids can flow. Can solids flow? The answer to that is no. So gases and liquids are known as fluids. So if we reference fluids, we're talking about either a gas or a liquid. It can't be a solid because solids don't flow. But when they do this flow, they move from areas of high concentration to low concentration, and that is known as diffusion. For example, this guy had issues, but his particles started here and then they expanded out. They spread out, they diffused out away from the initial location. That is diffusion, where things go from areas of high concentration to low concentration. Looking at changes in state of matter. So here we have a graph showing you energy changes and time and temperature. So down here I have a solid ice that's going to melt. When it reaches a certain temperature, you'll notice the line goes flat. When it goes flat, what's happening is this energy is going to be used to break the bonds between molecules. So the solid's going to melt. And it's going to be a liquid. It's going to plateau. Liquid's going to become a flat line and become a gas. So this is showing you changes in states of matter on a graph. Out of curiosity, do solids have to become liquids, or can they go directly to a gas? And the answer to that question is they can go directly to a gas. This is a process called sublimation. So if you've ever messed with dry ice and water, that is sublimation. So changing directly from a solid to a gas. And it's also the reverse process as well. So for example, dry ice, carbon dioxide, changes into a gas when you put it in water. Ice cubes in the freezer gradually get smaller because some of these particles go from a solid to a gas. That is sublimation. All right, really quick review. Which phase changes require the addition of energy to a substance? What is it called when a solid becomes a gas? Can you give me an example? And how are the heat of fusion and heat of vaporization different? Which one of those do you think is going to be greater? To go from a solid to a liquid or from a liquid to a gas? When you get these answered, hit the play button and we'll continue on. All right, we've talked energy and we've talked about phase changes. Now let's talk energy transfer. So question, do melting, evaporating, and sublimating require the addition or release of energy? So if I'm melting, evaporating, or subliming something, am I adding energy or taking it away? Well, in this case, I'm going to add because ice has to gain energy in order to melt. Water has to gain energy in order to evaporate. And so if those two require energy, then sublimation's got to require it as well. The reverse process for melting is known as freezing. And so freezing goes from a liquid to a solid. Evaporating has a reverse process of condensation, which is going from a gas to a liquid. We can look at these states of matter and look at the direction of energy transfer. So we're going to go from blank to blank, and then it's either going to be gained or lost here. So melting goes from solid to liquid. Energy is gained. Freezing goes from a liquid to solid. Energy is lost. I'm going to let you do the next three. If you have questions, come see me. But this is a great test to see how we're doing on this content. A great check to see how we're doing. Kind of a checkpoint. In talking about energy, which phase changes require a substance to lose energy? And where does that energy go? So we're going to look at these and go here. So I guess, which phase changes? So if we look at this, the blue arrows are going to indicate losing energy. So condensation is going to lose energy, and freezing is going to lose energy. Subliming, melting, and evaporating all gain energy. But where does that energy go when they lose it? So they're going to release it. Where does it go? It actually heats up the surrounding air. So fun fact, when it snows, the air up in the clouds around where the snowflake condenses actually makes the air around it a little bit warmer. It gets warmer because that water vapor up there had to release it in order to freeze into snow. So the area around a snowflake gets a little bit warmer when the snow is formed. Not a lot of bit, but just a little bit. If we pretend an ice cube tray full of water has to lose 334 joules of energy, where does that heat go? And so if it's going to lose it, it's just going to release it to the surroundings and the area around it, which is why the area is cold around freezing water. If it needed to lose 334 joules and only lost 300 joules, would it freeze? That answer is no. It needs to lose all the energy in order to freeze. And maybe, I guess, some of that water would freeze, but not all of it because there's not enough energy lost. A couple more terms. One, we've talked law of conservation of mass, which is down here. Mass can't be created or destroyed. Energy is the same way. Law of conservation of energy says that energy cannot be created or destroyed, but it can be transferred. So this can be only transferred from one form to another. Sorry, I didn't get that in there. Only transfer from one form to another. Our last state of matter we're going to mention is plasma. Plasma is a high energy, it's got charged particles called ions going around it. This has the most energy of any of the states of matter. It's the most common in the universe because all of your stars are made of plasma. So examples are flames, neon lights, auroras, all of those are plasma. All right, here are some review questions for you. Which two phase changes require matter to lose energy? What happens to liquid water at 0 degrees Celsius? What happens to solid water at 0 degrees Celsius? What does the law of conservation of energy say? What about the law of conservation of mass? We've done this one, so do that again. And then what is plasma? Make sure you can answer those. If you have questions, please come see me. Otherwise, I look forward to finishing up this unit with you in the coming days. So thank you for your time and attention. Enjoy the rest of your day.